Hello everyone, I am R.Malathy from the Department of Mathematics, SNS College of Engineering. This is my third video of second series. Topic is Introduction to Two-Dimensional Random Variable, in particularly Discrete Random Variable. First of all, we should know what is discrete variable. Whatever we can count, that all comes under discrete random variable. We are having two types in this. One is countable, another one is countably infinite. Two-dimensional discrete random variables represent the pairs of outcomes with discrete probabilities. They are used in various fields such as finance, engineering, and probability theory. Definition and properties of two-dimensional discrete random variables. They are characterized by a joint probability mass function and joint cumulative distribution function. The properties are include covariance, independence, and conditional probabilities. Example of two-dimensional discrete random variables. Dice roll simulating two dice rolls and analyzing the sum of numbers as a random variable. Card pairs, randomly drawing a pair of cards from a deck and observing their suits as a random variable. The probability mass function of two-dimensional discrete random variable is probability mass function means when we are doing the discrete case, we should know the probability mass function. In one-dimensional random variable, we have come across with many distributions, binomial, Poisson, uniform. These are all comes under discrete random variable. Here we are seeing the two-dimensional random variable. No, so we should know the probability mass function of two-dimensional random variable. Here PMF express the likelihood of a two-dimensional outcome occurring. Properties is it must be satisfies non-negative and sum to 1 over all possible outcomes. Examples are creating a PMF table for a pair of fair six-sided dice. Marginal probability distribution function is the distribution function of component variable are called marginal distribution function, that is fxy of infinity comma y and fxy of x comma infinity are called marginal probability distribution function of y and x respectively. The definition is given the joint probability distribution function fxy of x comma y of the two random variable x and y, the marginal probability distribution function of x is fxy of x comma infinity and is defined as fxy of x comma infinity summation j probability of x comma yj. The marginal probability distribution function fxy of infinity comma y is defined as summation I probability of xi comma y. The joint probability density function, which comes under continuous random variable, joint cumulative distribution function, we can call it a CDF of two-dimensional random variable is, the definition is it is calculates the probability that a two-dimensional outcome is less than or equal to a specified value. Properties is it satisfied monotonicity, right continuity and the limit of the function at negative infinity. Marginal probability mass function of two-dimensional random discrete random variable is calculation obtaining marginal PMFs by summing joint PMFs over one variable values, and application is understanding the individual probabilities for each of the variable in the pair. Conditional probability mass function of two-dimensional random variable is it's measure the probability of one event occurring in relation to another event occurring. Calculating conditional PMFs using the original joint PMFs and marginal PMFs. Visual representation of two-dimensional discrete random variable, scatter plots and 3D bars. In scatter plots, graphing pairs of outcome to visualize their joint probabilities. In 3D bar chart, representing joint PMFs with height corresponding to the probabilities. Thank you. In this particularly we should know what is conditional probability. Conditional probability definition is y given x and x given y, x given y. In y given x, we have to write probability of x equal to xi and intersection y equal to yj divided by probability of y equal to yj. In y given x is probability of y equal to yj intersection x equal to xi divided by probability of x equal to xi. In denominator, the value should not be changing for cases, and then x and y value, corresponding x and y values will be changed according to the y given x and x given y. Thank you.